This is part 3 of our video on logarithmic functions review. This question number 3, says solve each of the following. So I have log base 2 of x plus 9 equals log base 2 of 3x take away 5. So there are a couple of different strategies for solving log equations. This is by far the easiest of those. When you have a log equation that has the same base, right, on the log on each side, and you only have one log on the left and one log on the right, you can solve by comparing the arguments. So if log base 2 of x plus 9 equals log base 2 of 3x take away 5, they both have logs, they both have base 2. If they're equal, x minus 9, whatever that is, has to work out to be the same as 3x take away 5. So all I have to do for this one is just set the two arguments equal to each other. So x plus 9 equals 3x take away 5, and then solve. So from here, I would move all of my x's to one side. I have more on the right than the left, so I think I might move this x to the right by subtracting x from both sides. That leaves me with just a 9 on this side. 3x take away 1x is 2x, and then take away 5. From here, I would add 5 to both sides. 9 plus 5 is 14, which equals 2x. And then I would finish off by dividing both sides by 2 to get that 7 equals x. Now, the thing with log equations is that you cannot take the log of a negative or a 0. There just is no value because there's no way to use an exponent to turn a base of 2 into either into a negative or a 0. So what we need to do is check to make sure that x equals 7 works in the arguments for the original equation. So we are going to check to see if I put 7 back into my original arguments, do I either get a 0 or a negative, which I cannot take the log of. And those are called extraneous answers if they do work out to give us a negative or a 0. So I often don't actually write the checks down. I just do them on my calculator, and if it's okay, I move on, and if it's not, then we cross it out. But because it's our note, I am going to write it down. So I'm going to check for extraneous answers. And that really just means that the argument is 0 or negative. And you cannot take the log of a negative number or a 0. Okay, so all I'm going to do is take the argument x plus 9. Everywhere I see an x, we're going to put in our answer of 7. So 7 plus 9 is 16. Is that 0? No. I think my computer is frozen. Oh, we might be okay. So I put in 7. 7 plus 9 is 16. And then I want to know, is that a 0? No. Is it negative? No. So it passed the first bracket, so it's good. Then we're going to check the second one. So 3x take away 5. Everywhere I see an x, we're putting in a 7. So 3 times 7 take away 5. That is 21 take away 5, which should be 16. I don't care that they came out to be the same number, right? Depending on the equation, they may not. What I care about is that they're not a 0 and they're not a negative. So this check doesn't tell me if my answer is right. It just tells me whether or not my answer is invalid for the question that was being asked. So we are okay with that answer, and we don't have to worry about it. If it wasn't, I would cross it out and write extraneous, and then there would be no solution to this question. Okay, second question is a little different from the first one. It only has one log. So this one says log base 3 of x minus 1 equals 5. So for this one, I don't have a log on each side. So there are two different things you could do. Number one, you could try to write 5 as log base 3 of something. That is one strategy, and then solve it the way that we solved the previous one. However, what I prefer to do is Since there's just one singular x here, I like to rearrange and solve for x. So what I would like to do is find a way to get rid of a log base 3. So the opposite or the inverse operation of a log of base 3 is a power with a base of 3. So what you can do is bring that log base 3 to the other side by doing 3 to the power of 5. So this would equal x minus 1 equals 3 to the power of 5. So the inverse of a log base 3 is an exponent with a base of 3. And then from there, all I have to do is calculate 3 to the power of 5. I can use my power sheet. I could use my calculator, or maybe you happen to know that one off the top of your head. It is 243, says my calculator. And then I'm just going to add 1 to both sides to get that x equals 244. Now I do need to check, but as I mentioned in the previous example, I don't normally write that check out. I usually just do it on my calculator. So I look at the argument. That's the only thing we're worried about. X take away 1. I'm going to do 244 take away 1 and then ask myself, is that a 0? No. Is that negative? No, which means we're good. It doesn't mean it's the right answer to the question. It just means it's not invalid for the question. All right, we have one more question to go here. So I have log of x plus 1 take away log of x minus 1 equals 1. So in this question, I notice that I have 2 logs, and on the other side, I have a number. So I need to do something to maybe merge these 2 logs together. So I'm going to try to use one of my log rules, and we do have a log rule that says that when you are subtracting 2 logs with the same base, you can combine them by dividing their arguments. Now, do these have the same base? They don't actually look like they have a base at all. They secretly have a base of 10. Anytime you have a log without a base being written, it is always base 10. So I have the same base, so I can merge these together. So this is going to be log base 10. You don't have to write the base 10, but you'll find in a minute it actually will help us, of x plus 1 over x minus 1. And then that still equals 1. Now, x plus 1 over x minus 1, they're not the same bracket. It doesn't reduce, right? I can't really factor or do anything with that. So I'm just going to proceed with solving. I see that there's a log on one side but not on the other. So I could try to write 1 as log base 10 of something. Or what I prefer to do is take the log base 10 to the other side by doing the inverse of a log base 10, which would be a power with a base of 10. So if I brought this to the other side as a power with a base of 10, this would become x plus 1 over x minus 1 equals 10 to the power of 1. 10 to the power of 1 is just 10. So I have x plus 1 over x minus 1 equals 10. And then I need to solve, and it's a rational equation. So my preferred strategy for rational equations is cross multiplying. This 10 is secretly over a 1. So I'm going to multiply x plus 1 by 1 and x minus 1 by 10. So 1 times x is x. 1 times 1 is 1. 10 times x is 10x. And 10 times negative 1 is negative 10. All right, I do notice that I have x's on both sides. I don't really like that. So I'm going to maybe move this x to the other side by subtracting x from both sides. That leaves me with 1. 10x take away x is 9x. And then take away 10. I would then add 10 to both sides. That would give me 11. So 11 equals 9x. And then I would divide 11 by 9 to get 11 over 9 equals x. Now, it doesn't say in the question that it's okay to use a decimal, or does it? Nope. So I'm just going to leave it as 11 over 9. All right, I do need to check Like I said, you can write it out if you want to. I really just tend to do it on my calculator. I am checking only arguments. So x plus 1, pretty sure that's not going to give me a 0 or a negative. I'm just going to do 11 divided by 9 plus 1. I got 2.222. That is not 0. That is not a negative. We're good. Then I'm going to try x minus 1. So 11 divided by 9, take away 1, is 0.222, also not 0, also not negative, meaning it is okay, right? If it wasn't, I would cross it out, and then I would say there were no solutions, but it is okay. Not that it's correct, but just that it would work in that equation. If I put that number back into the equation, I wouldn't get an error. All right, that's it for our logarithmic function review. I can catch you in the next video to take a look at some exponential review.